Hello, everybody. Hope you guys are doing great. Uh, Today, we are going to talk about components of a vector. The first thing that I'm going to review is, as you guys very well aware, that a vector is any physical quantity that has direction and the magnitude. So, to represent any vector, we usually draw a line. The length of the line shows the magnitude, and arrowhead shows the direction. Like if you say, if there is a displacement of 50 kilometer, so we will draw the displacement vector 50 kilometer to the 8 displacement vector, and it may be represented by, let's say, d, and I can say this is 50 kilometer to the east. So what I will do, I will just make a scale, and according to the scale, I will draw a line. For example, my chosen scale is 10 kilometer, representing 1 centimeter. So I will draw a line to the east that will be 5 centimeter in the length, and it would be represented by D. So this is when any vector is in a particular direction, north, east, west, south. But whenever a vector is in a plane, what is plane? You know that plane or rectangular coordinate system says that we have x-axis positive, or you can say the right direction, like the east, and then y positive. You might have say this is the north direction, and the other two directions may be south downward here, and the west to the left. For example, if there is a displacement vector, and this displacement vector, the same one, is rather to go east, if this is making the displacement vector d is, for example, 50 kilometer at some angle, let's say 30-degree north of east. So what will we do? We will draw a vector in a plane that is making an angle 30-degree from east to north, and this is the same 5 centimeter, and we will draw the line as it is in the plane. But now whenever we have any vector inside the plane, so you can see that to reach the starting point to end point, we, if you start from origin, you are going to the east somehow, and then you will move from this point to this point to the north. So this is, you can say, eastward distance, displacement eastward, and this is toward the north displacement. So if any vector is inside the plane, you can see, to draw it in the plane, you might need two dimensions, that is along the positive x-axis and along the positive y-axis. So these parts toward east and north are somehow called components. So what you will say, you will say a component of a vector. A component is part of a vector in a vector in a particular direction. So when you are going to talk about this particular direction, so that particular direction may be toward east, toward north, toward positive x direction, toward negative x direction. Depending upon this, any vector can be described in components in this way. For example, if you are having this same situation and there is a displacement vector, for example, seen here, this is the positive x-axis, this is the positive y-axis. We are having a displacement of vector. For example, this displacement vector is d, that is making angle theta with x-axis. So this particular vector has two parts, as I showed you in the previous example. These two parts may be one along the this direction, that is horizontal direction. So I will name it dx. This is the horizontal component, and the other one that is along y-axis, this will be named as dy. So depending upon this, we distribute the components into two parts. So these components are, one is called horizontal. Horizontal component is also called x component, horizontal or x component, and the other one that is along y-axis, you can say this one as vertical or y component. So vertical or y component, we will name it. So whenever we have any vector d, it may have two components. One is horizontal component, as I mentioned here. The horizontal component is denoted by e dx, and this can also be called the eastward displacement. So how to calculate this value? To calculate this value, you can see these two components are actually rectangle to each other, making 90 degree. So we have a right triangle in which dx is base, dy is opposite, and d, the displacement vector, is the you can say hypotenuse. So to calculate dx and dy, we will use this triangle, and triangle geometry says that if d is given, then what do we have to find dx? So I will go to use uh, cosine theta. You know that cosine theta is opposite over adjacent. Opposite is uh, cosine theta is adjacent over hypotenuse, sorry. Adjacent is dx and hypotenuse is d. So I can say dx is equal to d times cosine theta. Similarly, if we have to find dy, so what you will do, you will use that d sine theta we will use here. Sine theta is dy, the opposite over hypotenuse. So d y will become d time sine theta. So whenever we are going to find any component of a vector, so we need to check if it is horizontal component or vertical component. There is one more thing that we need to remember, that horizontal component is a component that is along x-axis or that is along eastward, but sometimes this horizontal component is related to the angle theta. If angle theta is given in this direction, so horizontal component is along x-axis. But if I change the figure, and this figure comes like this, and you might say that this is x component, this is x-axis or y-axis, or you can just simply say this is the eastward direction and this is northward direction, and angle for this vector, let's say this is the velocity vector now, the velocity at any angle theta. So in this case, your components might change. For example, you can say this component is now toward northward will be horizontal component because this is the adjacent horizontal component, and we will calculate it if this is v. So to calculate this, we can say that v cosine theta, and this will be air in this direction. This is now vertical because it is opposite to the theta. So this will be V sine theta. Similarly, if you have diagram like this and we have components, for example, this is this one. So here in this case, whatever you have, for example, this is the velocity vector, so this is theta. So this part is now is dx, that is d cosine theta. And this part, you can draw it here, or you can draw it here. This will be d sine theta. But on the other hand, if the vector is in this coordinate, that is in the negative direction, so if theta is given this one, so similarly, this will be dx, but this time dx will be negative because it is in the negative direction, so it will be negative d cosine theta, but dy in this case is upward, that is upward positive, so you can say d sine theta is dy. So this is how we can change our different calculations according to the component. Let me give you an example here, and to understand the example, uh, we can easily find out the understanding of the component. For example, if this is an example seen on your screen, there are many vectors shown here, and all of these vectors which you can see are actually uh, the vectors. uh, Different names are shown for these vectors like d1, d2, d3, d4, d5. So all of these vectors which are shown here, we can check that what are the values of these. This is the vector. So first question that is written number 5 is saying how many displacement vectors shown in the figure above has horizontal component. So if I see here, this is d1, it has horizontal component. This one, that is d1x. On the other hand, when you have d2, it is on y-axis. It does not have anything along horizontal. d3, it has horizontal component, that is d3x. d4, its horizontal component will be here until here, d4x, and then d5 has horizontal component that will reach from here to here. So this is d5x. So there are four horizontal components of out of 5. The next part of the question is saying how many displacement vectors shown in figure have their components that lie on y-axis and are point in the negative y direction. So here we are going to find the y components. Let me close this one and discuss about the y components. So when we are going to talk about y components, so the y components here in this figure are for each of this. For example, this is D1. D1 has Y component. You can draw it here or here, I told you. So this is D1Y and this is D2Y. Sorry, D3Y. D2 is already like D2Y. It is same because it is uh, only on y-axis, and D5 is showing here. This one is D5Y, and the other one until here you can say d4y. So here what we found is there are two in downward direction, that is negative x direction. This is d4, and d5 is until here. So two are in negative y direction, whereas the rest are upward. So we can say this is on the positive y direction. So this question answer is there are three components that are on negative x direction. Sorry, three component, not three, sorry, two are on negative y direction and three are on positive y direction. So your choice will be this. The last one, which displacement vector shows vertical component are equal? If you look at the diagram which I tried to show the components, you can see d1y and d3y are equal in value. If you are not understanding, you can just see here. I will redraw this all. Let me erase this one. For example, if I try to draw these two components here, this is the point for d3. This is for d1. If I draw the line from here, so you can say from this point till this point is d1y, and similarly d3y is from here till here. So you can see both of these are equal in value. So d1 has d1y which is equal to d3y, so which are equal. So d1 and d3 are having the components which are equal in magnitude. Okay, so until now we just came to know that every vector has two components. So let us try to find the value of a given vector. For example, if I say that there is a velocity vector, for example, a car. So let me give you an example, and I ask you a car has a velocity of 50 kilometer per hour in 30° northeast. So how much eastward and northward it will move? North it travels. So even we don't need the figure here, but just to show you, if this is north and east direction, this is east and this is north direction, this is the velocity of the car. Let's say this is 50 kilometer per hour. 50 kilometer per hour, this is velocity v. So this velocity is making angle 30° with x-axis. So eastward mean they are asking about Vx. So this component Vx they are asking us. So Vx you will find by V times cosine theta, and V is 50 times cosine 30. So when we are going to find 50 times cosine 30, so you need to hold your calculators, and in the calculator what you need to find, you need to write the value of cosine 30 and multiply it with the 50. So let me try it. What do we have here? For example, I wrote 50 times cosine 30. So answer I got is 25 root 3, and in decimal this is 43.3. So I got it northward, it is sorry eastward, it is 43.3 meter. It will kilometer, sorry, kilometer per hour is the velocity. So eastward velocity is this one. And when you are going to find the northward velocity, east and northward, not travel, we will say velocity, east and northward velocity components. So when we are going to northward, for northward, this is upward, that is Vy. Vy is equal to V sine theta. As you know that V is 50 and sine 30. Sine 30 is half, so your answer will be 25 kilometer per hour. Okay, this is one thing that we need to remember. But there is very important thing that we also need to see. What is that one? If the question changes and this question goes like this one, for example, there is this diagram for just for understanding. If this is the diagram and this is that some object is moving from origin to this direction and this is making angle 30° with y-axis. For example, this is 10 meters distance. Now this is, for example, displacement d. So if I ask you how much northward it will move, so to find the northward you will use here until this point, sorry. So this will be dx. As I told you, because theta is here, so now this will be dx northward and this will be dy. So because wherever the angle is, keep it in your mind, the angle represents the horizontal component. So here you can say dx, that is to the north. So dx, that is to the north, will be equal to 10 times cosine 30, and dy, that is showing to the east. So this will be 10 times sine 30. So when you will find their answers, so you can easily say 10 times sine 30 will give you 5 meters to the east, and 10 times cosine 30 will give you 10 times cosine 30. It's giving me 5 root 3 or 8.66. So this is 8.66 meter. So this is how we can use the component. Now, getting to the second part of the same lesson, when we are having a vector components, how to find the vector. For example, if you are having two vector like components, the rectangular components x and y. If this is the situation, let me try to draw it. If this is the situation, this is x-axis, this is y-axis, and you have two components of displacement. If anything, let's say this is dx, you know the value, and this is dy, as you know that dx and dy are perpendicular to each other. So this is it, you know this one, and you are asked to find their resultant vector d. So as you can see, this d is looking like a hypotenuse, and we will use Pythagorean. So using the Pythagorean, you can say hypotenuse square d square is equal to dx square plus dy square. And now if you are going to find d, so this will be square root of dx square plus dy square. Now this is the magnitude of the vector. You know that any vector that is uh, to find, it has two things, magnitude and direction. And as you see in this triangle, we are having horizontal and adjacent and opposite. So we will use tan theta to find the direction, and tan theta is opposite dy over dx. So this will be theta is equal to tan inverse dy over dx. So if the vector is, for example, vx and vy, the components are given, so this will be magnitude will be v is equal to vx square plus vy square, and theta will be tan inverse vy over vx. For example, if I give you two components here, or the similar question, if I try to show you, I can say if this is component toward east, for example, this is 4 meter, that is toward the east or dx, and from here you move 3 meter to the north, that is dy, that is 3 meter. Now how much displacement you covered? So to know the displacement, what you will do, you will quickly use d magnitude, you will use d is equal to dx square, means 4 square plus 3 square, square root. So this will be 16 plus 9, 25, that is 5 meter. So now this is d. Now the second thing is the direction theta, that can be mentioned with the horizontal axis. So this theta will be tan inverse dy over dx, mean 3 over 4. Hold your calculator and press tan, shift tan 3 over 4. So you get the answer 36.87. So 36.87, I am just rounding it to 37 degree. It is from east to north. So you can say from east to north or northeast. So this is how we can find the vector if we are having the components given. Okay, now the third part of the same lesson is if you are asked to add two vectors, and for addition of the two vectors, if you have to use the components, we need to follow some steps. So to understand this, let me start with the example of the given in a Giancoli book, that is related to a mail carrier displacement. As you can see from the question, you can read from the statement, we also need to look at the diagram. I will not try to draw it first. I will try to give you the steps, and then we will go for it. So rural mail courier leaves the post office and drives 22 kilometer in the northerly direction. So keep it in your mind. This is the O is the post office. This is the post office. So she leaves from here to here. So the first displacement is toward north. that is 22 kilometer. So D1, she moves 22 kilometer toward the north. So 22 kilometer toward north, and then she drives directly 60 degree. This is the 60 degree. So for 47, so D2 is 47 kilometers. So where she is now, she is at this point from here. So the question is, how much is her displacement from post office this to this? So our question is to find this D. Okay, to find this D, what would be our first step? So please keep it in your mind when we are going to solve uh, addition of vector by this component method. So first step is we need to find the rectangular components. So the first step is to find components. Components. So first step is to find components. There are two vectors D1 and D2. So if you look at these two vectors, I will just redraw it. So D1 is in the north direction. So it is understood when a vector is in the north direction, this is D1, and this is x-axis, and this is y-axis. So this is D1, which is on the y-axis. So this is D1, which is 22 kilometer. Now you can see this D1 is in the y direction. There is not any part on the x direction. So without any formula, I will just say that D1x d1x is equal to 0. But if someone says that no, I need to use the formula d1x is d1 cosine theta, so here theta from the x-axis is 90 degree. So you can say 22 cosine 90. So 22 cosine 90 will give you 0 as well. Okay, d1y, because full value of the component is vertical on the y-axis, so d1y will be total 22 kilometer. So here, if someone says, no, I need to use the formula d1y is equal to d1 sine theta, yes, of course, you can use d1 22 sine 90. So you can use it. So here, I'm just writing for your reference. If you want to use d1x, so you can say d1 cosine 90 degree because it is making 90 degree with this, and d1 sine 90 degree. Okay, so I just found the two components of the first vector. Now getting back to the second vector. In second vector, if you look here in the diagram, the second vector is looks like this one. If I retry to draw, this is the x-axis and this is negative y-axis, and the second vector is in this direction. It starts from here till here. So if this is so, this is your D2. So in this D2, you have two components. If you look at this, so this will be D1x that is positive, and D1y is going downward. So you can say this is D1y. So now D1y is going down. It means negative y-axis, so we will keep it. We will put negative from our own. Now getting to the point, how to calculate, sorry, my mistake here, it is D2, not D1. So this is D2x and the other one is D2y. So finding D2x, what I need to do, I will just say D2x is equal to D2 cosine theta. The value of D2 was 47. So I will say 47 cosine 60 degree. And when I use the calculator, I will say 47 times cosine 60 degree, and I got 47 over 2, that is 23.5. So this one is for me 23.5 kilometer. Okay, that is eastward its distance. Now d2y, as you know, that will be equal to 47 sine 60. So 47 sine 60, when I am trying to find 47 times sine 60, so my answer is 40.7. And this one, as I told you, should be negative, so I should write here d2y is equal to 40.7 with negative sign, negative 40.7. Okay, here, as I told you in the beginning, this is our first step that give us the value of the components. So we did find the components of the vector. Now the second step is we will add the components, like first I will add the x component. So step T is I am going to find uh, dx, and that will be I will add the components, but I will add the components x with x and y with y, x with x and y with y. So it will become dx is equal to d1x plus d2x, and here dy will be equal to d1y plus d2y. So I need to add these vector components to find their uh, result in horizontal direction and in the vertical direction. So the first scenario is I am going to go for the dx. So as you know that d1x was 0 and d2x was 23.5. So what I will do, 23.5 plus 0. So this gives me dx, and dx is 23.5 meter. Whereas dy is, you know that it was d1y was 22 uh, plus negative 40.7. So this is 22 plus negative 40.7. This is giving me 18.7 with negative sign. So dy, I got it negative 18.7. So what I found here is that I got horizontal component positive. This one is the positive one, whereas dy is negative one. So my drawing will be here. This is dx to the positive direction, and dy will be to the negative direction. What is negative direction for dy? Negative direction mean it will be pointing downward. So I will approach to the downward direction for this. So the triangle will be here to the positive direction and the negative y direction. So I can just simply say this is dy. And now where is the next step? Because this shape you can see here is dx and dy. So resultant, when I will go to find, so these are two components. So resultant will be this. As I mentioned you, to find the resultant, what I need to do to find the resultant, I will find the magnitude by the Pythagorean, and the direction by the tan theta. So quickly I will go to the last step, and last step is giving me that I have to go to this. So where is the step 3? I am going to here. Step 3 is finding the result, its resultant displacement. So find the result displacement, find d. So to find d, what is I am going to do is to find the result d. As I mentioned earlier on, I will just quickly have to use the Pythagorean, and as Pythagorean for dx square and dy square, so I can say it is square root of 23.5 squared plus negative 18.7 squared. But keep it in your mind, you will write it in the brackets. So this is giving me 30.03. So what I will do to find the magnitude, I will use dx is equal to, my mistake. I will say d is equal to, sorry, it's lagging. So I am just quickly saying here, let me erase it. So what I was saying, that magnitude of d, magnitude of vector d is equal to radical dx square 23.5 square plus negative 18.7 square, and this is giving me 30.03, and this is kilometer. Now to find the direction theta, as I told you, you will use tan inverse. Its vertical component here is, you can say, it's lagging and not writing. Let me rewrite it again, please. This was 23.5 plus negative 18.7 square, and this is square root, is equal to 30.03, and theta is equal to tan inverse. Dy was negative 18.7 over 23.5. So this will be, I'm going to write shift tan negative 18.7 divided by 23.5. So this is giving me negative 38.5, so which means that it is around 39 degree, and but it is in the downward direction, as you can see here in the diagram, that is going downward. So this is all about, so I'm hopeful that you guys might have understood this one. So this is, you can say, 39 degree, and negative which show is in with, this is negative 39 degree, so you can say it is downwards, or uh, below x-axis, so you can write below x-axis. So you will write it below x-axis, and above answer you can just simplify it to uh, 30 kilometer. So it is the resultant. Thank you so much, and bye 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 for now. So this is it. So try to review it and try to understand whatever we